Okay, everybody, this is a quick review of factoring, which we're going to be using a lot in Chapter 4 when we're talking about solving polynomials and finding zero. So we need to have a kind of a solid grasp of all different types of factoring before we leap into that. So just a quick review on that. So first of all, remember you always look for a GCF first. GCF, remember, is the greatest common factor. So when we look for our factoring situations, when we're trying to break things down into the things that multiply, when we're trying to multiply things together, we always have to look for the biggest thing we can pull out first. So factors, remember, are just numbers that multiply or expressions that multiply together to get this final product. So when we look at this first one, 3x minus 6y, what has been multiplied together to make that statement? Well, the first thing we look for is what's the biggest number or variable we can pull out of both of those terms. Well, numerically, it looks like we can pull out a 3, and there are no variables that appear in both of those terms, so we can't pull out anything else. What's left inside goes inside parentheses here, so it's kind of the opposite of the distributive property. What would we multiply 3 by to get the first term? It would have to be x. And then 3 times what would give you a negative 6y would be a minus 2y. So when you check your answer, if you distribute it back out, you should always get back to the original. So you think about what can I pull out of every term? And let's take a look at the second one. So look for the GCF. Number-wise, looks like 9, 54, and 81 are all divisible by 9. So I can pull out a 9. And it looks like all three of those terms have a y in there, y to the first. Can't take any more than that, though, because that middle term doesn't have more than one y. X doesn't appear in all of them. All right, what's left inside? So you're starting with what I would call a trinomial. 1, 2, 3 terms. Trinomial. That means inside, we're going to have 3 slots. So we need to think about what would you multiply 9y times to get each of those terms. Or take each of these terms and divide it by 9y and see what you would have left. And that's another way to think of it. So you can think of it really either way. So 9y times what would give you the first term? Looks like we need an x and another y. And then 9y times what would give you the middle term? That would be plus 6. And again, we need an x. And then for the last term, 9 times 9 is 81, and it looks like we need one more y to the first. So that would be pulling out the GCF. And again, if you distribute back out, you should get back to the original expression. So always look for a greatest common factor first. All right, let's talk about trinomials. Quick review on this. A lot of people spend some time talking about the signs. What does this look like? This is the reverse of FOIL. So when you think about FOIL, that stands for first, outsides, insides, and lasts, those products. So when we look at this x squared is coming from the product of the first, the 7 is coming from the product of the last, and this one is what I call the OI, the insides and the outsides together. So when you add those two terms, that should give you the middle. So when we're thinking about trinomials, if they factor into 2 binomials always, and that's where this FOIL comes from. So the things that would go in the first positions have to multiply together to give you this x squared. So it would have to be x times x. Excuse me. The last terms, the product, have to give you a 7. So here's where you have to think about your factors. Things that multiply to 7 that would add to that 8 in the middle. So that's where people start thinking about, okay, what multiplies to 7, what would work? Well, there's only one pair of numbers that multiplies to 7, so that's going to be pretty limited. It's only 7 times 1, and 7 plus 1 is definitely our 8. The other thing to look at are your signs. If everything's positive, well, then everything has to be positive. So plus 1, plus 7. If you check your answer, insides would give you a 1x. Outsides gives you a 7x. And when you add those together, 1 plus 7, that's your common factors. You would get that 8x in the middle. Some people have a really easy time doing this, and for others it's really difficult. So you really just need to list all of your possible factors and just keep trying until you find the pair that when you do the outsides plus the insides, those two products added together, you get the number in the middle. All right, let's take a look at the next one. So first, x times x. Last term is a negative, so let's talk about that. If the last term multiplies to give you a negative, that means your signs have to be opposite. So one's a plus and one's a minus every single time. Doesn't matter which order you write them in, it's just I know I have to have both of those. There's no way to multiply to a negative in any other way. Okay, so we need numbers that multiply to 21. So like 1 times 21, 3 times 7. Those are the only factors. Okay, which of those pairs have a difference of 4? Because remember, one of these numbers is going to be positive, the other one's going to be negative, so when you add them together, they have to have a difference of 4. Well, it's got to be the 3 and the 7. And because it's a negative 4 in the middle, that means the bigger of those two numbers has to be the negative. So that means we would have a minus 7. Sorry about that. We don't need to have that in there. A little email coming through. So minus 7, and then the other one would have to be a plus 3. So they add to a negative 4. So if you check your outsides plus your insides, they would add to negative 4. So think about the signs. That really helps. All right, now take a look at the last two. For both of these, a little bit different. Can you tell what's different about them? That leading coefficient is not a 1. Just makes it a little bit more involved when you check your outsides and your insides. It's not quite as easy to plug things in. So let's take a look and see how we'd handle that. Still no GCFs in any of these, so I can't pull anything out. But now the first position is a 3x squared. So you have to think about, well, how do I get a 3? There's only one option, which is wonderful when these are prime. That's the only thing it can be. It has to be a 3x and a 1x. How do you get a 6? Well, we got some choices. It could be a 1 and a 6. A 2 and a 3. When the number out front, that leading coefficient isn't a 1, now I'm going to have to take a look and actually try the different pairs, put them in both orders, and see. I can't just say, okay, which one adds to 7? Because I'm having to actually, remember, it's always the outsides plus the insides. So when you multiply, you've got another number in there. So it's a little bit more involved. But I do know that because it's a negative 6, one of the signs in there is going to be plus and one's going to be minus. So you can just kind of mess around and see what works. I'm going to do plus minus this way, and I'm going to choose to try first the 2 and the 3. I'm guessing it's this. So I think if I put the 3 here and the 2 there, let's check. Outsides, that would give me a negative 9x. Insides, that would give me a positive 2x. And when I add them together, excuse me, I get a negative 7x, that term in the middle. So when you're adding them together, that's where you have to check. You actually have to do the outsides plus the insides. All right, let's try one more like that, and then we'll get on to some special kinds of factoring. No GCF again in this one. Can't pull anything out. First term is 5x squared. Again, that makes life pretty easy. There's only one possible pair that multiplies to 5, and that's 5 and the 1. Again, the last term is a negative, so I know my two signs are going to be negative. I think it goes this way. This one's not quite as bad either, because to get a 2, you only have one option as well. It's a 2 and a 1. So where should I put the 2? Where should I put the 1? I'm trying to make a 9. I think if I put the 2 here and the 1 there, outsides would give me a 10x, insides would give you a negative 1, and those two add up to 9x. So we get that 9x that we needed in the middle. This is trial and error. It's a lot of guess and check and just see what works. A lot of people get frustrated and they mess up their arithmetic and they think the pair that they've already tried doesn't work when it really did. So just take your time, make sure you check all the possibilities. Okay, let's start talking about a few special things to look for when you're talking about factoring. So difference of squares is one, and let's talk through what that means. It means you have just two terms that are both something squared, so they're both perfect squares, and difference means subtract. And when you look at their factors, they always factor into two binomials that are identical, but one with a plus and one with a minus. When you multiply those two binomials together, the OI, the insides and the outsides, those two terms that you get, cancel every single time. They add to 0, and that's why you end up with just the squared term. So it's a really common thing, and if you recognize it, it helps you understand what you need to factor it. So if you see two terms that are something squared, difference, that's difference of squares. So look for those two terms. So first thing you check for, though, always remember GCF first, and in this one, we definitely have a GCF to deal with. So what can we pull out of both of those terms? Looks like a 2, and I think both of them have a C and both of them have a D. So I'm going to pull that out first, and what that's going to leave me with is it looks like C to the 6th, D to the 2nd, and then minus 225. So make sure you pull out GCFs first. That's still in play. So that's going to be out front. Now the question is this expression inside this binomial, is that a difference of squares? And it sure looks like it is to me. Those are both perfect square numbers. So what do you multiply together to get C to the 6th? That would be C cubed. D to the 2nd would be D. So that's our first. Difference, so that means it's a plus and a minus. 225 is a perfect square. What squared is 225? That is 15. So plus 15 and minus 15. If you did your FOIL, the outsides and insides would cancel and you'd be left with those two. So your final product is all three of those factors, the GCF and both of the binomials. So if you multiply that all back out, you'll get back to the original. All right, now take a look at the next one. This is a little crazy. The difference of squares, here's your minus. Here's the first term. There's the second term. They're both something squared. It's just that the second term happens to be a binomial that's being squared. Totally fine. That's still a difference of squares. So let's take a look and see how you'd break it down. First one, what squared gives you 16x to the second? Well, that would have to be 4x and 4x. It's a difference in the middle here, so that means one's a plus and one's a minus. Now our second term, do this in a different color. This is the second term. What is being squared? Well, the entire binomial is what's being squared. So when I put it in here, I have to put in the binomial, 3y minus 1 and 3y minus 1. Notice the parentheses, right? Because it's that's being squared. I know that looks a little goofy, but you can do difference of squares or any kind of factoring with expressions as well, so it gets a little bit more involved. Okay, last couple of things to look for. Factoring by grouping. Key thing here is 4 terms. You'll see 4 terms and we can group them together. So see if you remember this from advanced algebra. I'm going to look at it in the way that it's written to start with. If it works, great. If it doesn't, you may have to shift the terms around, but usually they have it set up so that it's ready to factor as is. So when you look at this first part, what can you pull out of those first 2 terms? So think of the GCF just of the first 2. Looks like what they have in common is an x squared, and that would leave you with a 2x plus 1. Do the same thing and see what you can pull out of just the second 2. Looks like I can pull out a 4, which would leave a 2x plus 1. So here's what I want you to notice. If you think of this entire expression as your term number 1 and that entire expression as term number 2, they have something in common now. What is the GCF for those 2 red underlined terms? What do they each have in there? Well, they each have a 2x plus 1. That becomes your GCF. So when you write it as a final product, how we always do a GCF, we pull out what's in common. So the GCF would go out front, and what's left goes inside that second set of parentheses. In other words, what you'd have to multiply by. So my GCF, what I'm going to pull out of each of those terms is this, just like you pulled out the GCFs in those first 2 steps. So I'm going to pull out 2x plus 1. That's my GCF. Now what's left in each term when you do that? In the first term, if you pull out the 2x plus 1, all you have left is the x squared. In other words, to recreate this first term, you would have to take 2x plus 1 times x squared. All right, now what's left in the second one? If I pull out the 2x plus 1, well, it would be a 4, and the sign in between is plus, so plus 4. So if you look at what you end up with, you end up factoring by grouping into 2 binomials. And if you wanted to check your answer, these were the leftovers here. If you want to check your answers and do FOIL, just take a look quick. I'll do it on this first one. If you multiply it out, 2x times x squared would be 2x cubed. Outsides, we get plus 8x. Inside, we get 1x squared. And then last, you get 4. Just a little rearranging here to put it in descending order. And if you look back, that's exactly the same expression you started with. You factored it by grouping. So you're looking for that GCF in each of the pairs. And then hopefully what's left inside when you do that, it should be the same and you can pull it out again. So grouping is really looking for GCFs over and over again. So let's try that once more. So look at your first 2. What can we pull out? Looks like c to the second. So we'd have 5c plus 2. Now careful on the next one. I'm going to pull out a negative since both of those terms are negative. Looks like I can pull out a d squared out of each of them. And that would leave a negative times a positive 5c. And a negative times a positive 2 would give me those 2 terms. So be careful on those signs. Now look at what you have left over. Each of those has a common binomial factor of 5c plus 2. So I'm going to pull that out front. So my GCF, 5c plus 2, and then what's left inside, what would I have to multiply by to recreate each of those first 2? Well, in the first term, I need the c squared. And then the second one, I would need the minus d squared. That's the leftover. So the GCF is what's out front, and what do you need to multiply by to get there? All right, now take a look at inside. We always want to do what we call factor things completely. The other ones, we really haven't had to worry about this, but look at this expression. That looks kind of familiar to me. That looks like one of those difference of squares, and I think I can factor that one further. So what do you multiply by to get c squared? C times c. What do you multiply to get d squared? D times d. And it's negative, which means 1 plus and 1 minus. So this one, you can actually go all the way down to a product of 3 factors again to get back to that original. And you can multiply them all out and see that it works. So factoring by grouping, look for those 4 terms, and make sure you always factor completely, go as far as you can. Okay, last thing we're going to talk about is sum and difference of cubes. There are formulas for these that you can work through. These are always true. It's something you can look up. If you multiply it out, it works. You just have to recognize if it's something cubed. So don't forget GCF first, right? That's really important. So GCF first, and we can pull out that common factor. So what can I pull out of both of those terms? Looks like a 5 and an x, which is going to leave me with x cubed plus 8. All right, so the GCF is going to help me see that what's left inside, that's a difference of cube or a sum of cubes. So that's the second formula down at the bottom. So we can always factor that into a binomial times a trinomial, just following the format here. In our case, our a cubed is the x cubed, and our b cubed is the 8. So what am I cubing in the first one? Well, our x is like the a. And then what do you cube to get 8? That looks like 2. So our 2 would be the b. So when you think about writing this out, think about substituting in those values then. Just plug them into the same spot in the formula. So in our formula, the a is x and the b is 2, because that's what I'm cubing to get each of those terms. All right, so I'm just going to plug that in. So it starts with a plus b. So for me, a is x plus b is 2. Okay, then the next part, it says take the a value and square it. So my a value is x, so I need to square it. Then minus, so subtract, a times b. Well, my a is x and my b is 2, so that would be 2x. And then plus b squared. Well, b is 2, so square it would be 4. If you think of it that way, it's a lot easier way to go through that. So think of it like a formula. Figure out what are you cubing. Plug those values in for a and b, and it's a lot easier way to go through and do that. If you multiply out these 3 factors again, you will get right back to your original. Okay, so that's a quick overview. That's like an entire chapter in Algebra 1. Things to think about when you factor. So hopefully your practice will go well.